Hello student, in this lecture we will study the pass 1 of the assembler. In the last lecture we discussed about the data structures those are used by the first pass of the 2-pass assembler like the opcode table, symbol table, literal table and the pool table. And we also studied about the concept of how the entries are made in these particular data structures. Now we will start with the intermediate code forms. Two variants are considered for the representation of intermediate code, which is generated by pass 1 of the 2-pass assembler. The difference between these two variants is only in their operand fields. Now we will talk about the numeric opcodes of the declaration statement and assembler directives, which is shown in these two tables. So for the declaration statement, if the mnemonic is DC, so it will be represented as the machine code 1, and for DS it will be represented as 2. For the corresponding assembler directives, if your instruction consisting of the assembler directive start, so it will be represented as the machine code 1. For end it is 2. For origin it is 3. For EQU it is 4. And for LTORG the corresponding entry is machine code 5. Now we will discuss the variant 1 in detail. If the operand 1 is the register, then it is represented as the number from 1 to 4. That is, for A register you are going to represent it by the number 1, for B register it is 2, for C register it is 3 and for D register it is 4. And the 6 condition codes are represented as the numbers from 1 to 6. Now the operand 2 is going to be represented in the form of a pair, and that pair consisting of the operand class followed by the code. Now what is this operand class? The operand class can be either C, S or L for the constant or symbol or the literal respectively. If the operand 1 is constant, that is, if it is C, then the code represents the internal representation of the constant. And if the operand class is S or L, that is symbol or the literal, then the code represents the entry number in the symbol table or the literal table respectively. Now on this slide I have given one source program on the left side and the right side consisting of the variant 1, which is one of the intermediate code form. Now the first instruction of the source program consisting of the instruction start followed by 101. As all of us know that start it is a assembler directive, and as we have seen in the previous slide, the start is going to be represented as the machine code 1. So it consisting of the pair AD, 01. Now start is followed by the constant 101. So it will be represented as the pair, the constant that is C followed by 101. So your instruction start 101 having the equivalent intermediate code as in the first bracket we are going to mention AD, 01 and in the second bracket we are going to mention C, 101. Now for the next instruction the location counter will be set as 101. The instruction is read A. As all of us know that read it is an imperative statement and the corresponding code is 9. Now how to represent A? We will see the particular entry number for this symbol A in the symbol table, which is entry number 1. So it will be represented as a pair of S, 01. The next instruction consisting of read B. As the previous instruction, read will be represented as IS, 09, and for B we will look for the entry number in the symbol table and it is 2. So the B symbol will be represented as S, 02. Now the next instruction is move R C register followed by the literal 1. Move R is represented as IS and corresponding code is 4. Now as all of us know that A register, B register, C register and D register is having the numeric values from 1 to 4 and C register will be represented as 3. Now for this literal we will look the entry number in the literal table and for this literal the entry number is 1. So this literal is represented as a pair of L, 01. The next instruction is move R. A register, A will be represented as the imperative statement corresponding code is 4. A register will be represented as 1 followed by the symbol A entry is S, 01. Now the next instruction consisting of loop, add A register and the literal 5. So add it is the imperative statement having the code is 1. A register will be represented as 1 and the literal 5 is having the entry number 2 in the literal table. So it will be represented as a pair L, 02. The next instruction is move M A register R. It is the imperative statement having the code 5. A register will be represented as 1 and the symbol table entry number is 4 for the particular symbol R. So the entry will be made as S, 04. Now the next instruction is compare A register and B. So it is having the imperative statement followed by 6. The A register will be represented as 1 and B is having the entry number 2 in the symbol table. Next instruction is Bclt Loop. BC it is an imperative statement having the code 7. Now the operand 1 is either can be the register or the condition code. And here we are getting the operand 1 as the condition code where we are going to represent LT by its numeric code that is 1. And we will see the symbol table entry number for the symbol loop which is 3. So the entry will be made as S, 03. The next instruction consisting of the assembler directive which is having the corresponding code of 5 as per this particular table. Now the next instruction is subtract A register and the literal 2. So subtraction is the imperative statement having the code 2. A register is going to be represented as 1 and the literal 2 is entered as entry number 3 in the literal table. So we are going to make the entry a pair of L, 03. Now the next instruction is again equals loop. So EQU it is the assembler directive having the code 4 and loop is entered as the entry number 3 in the symbol table. So we will make the entry as S, 03. The next instruction is multiplication of C register and B. So this particular opcode is represented as IS, 03. C register is represented as 3 and we are going to look for the symbol table entry number for B which is 2. So the entry will be S, 02. Now the next instruction is add C register with the literal 10. So add is represented as imperative statement having the corresponding code of 1 C register is represented as 3, and 10, the literal 10 is having the entry number 4 in the literal table. So we are going to represent it by a pair of L, 04. Now, as we have seen this, for the declaration statement, if the mnemonic is DS, we are going to represent it by DL, 02. Now, the constant value 1, here it will be represented as C, 1. For the instruction BDS1, as it is a declarative statement having the code 2, we are going to make a pair of DL, 02 followed by the constant C, 1. And for this instruction RDS1, we will make the entry as DL, 02. In the next pair, we will represent the constant as C, 1. And the last instruction is end, and as all of us know that it is a assembler directive and having the code as 2. So this is the particular source program and its corresponding intermediate code representation in the variant 1. I think all of you got the clear idea about how to represent the variant 1, that is the intermediate code form of the corresponding given program. Now we will discuss about the variant 2. In this variant of the intermediate code, the operand fields are selectively processed. In declaration and assembler directive statements, operand fields are completely processed to support the location counter processing. For imperative statements, operand fields are processed only to identify the literal references. So when the literal occurs, it is entered in the literal table entry number, say n, and in the intermediate code it is represented as L, n. Now on this slide you can see on the left hand side the source program is given, and we will see on the right hand side it is the variant 2 that is going to represent the intermediate code form. Now for this particular first instruction start 101, as it is a assembler directive, the corresponding code is 1, and 101 will be represented as a pair of C, 101 because 101 it is a constant over here. The next instruction consisting of the location counter as 101 and the instruction is read A. Now, for this particular imperative statement, the operand fields are processed only to identify the literal references, and when the literal occurs, it is entered in the literal table entry number, say n, and in the intermediate code it is represented as L, n. If the particular statement is a declaration statement or assembler directive statement, then operand fields are completely processed to support the LC processing. And because of this, as it is an imperative statement, it will be represented as IS, 09, and A is going to be represented as it is. For the next instruction, read B, it is going to be represented as IS, 09, and the symbol will be represented as it is. For the next instruction, move R C register with the literal 1. The move R is going to be represented as IS, 04. C register will be represented as it is, but for the literal we are going to consider the particular entry number and it will be represented as L, n. The next instruction is move R A register and A. So it will be represented as imperative statement followed by the code. A register, the operand will remain the same and A will be also remain the same. For the next instruction, the literal entry will be represented as L,02. The instruction will be represented as IS,01 followed by A register and L,02. Then move M, A register and R will be represented as IS,05 and the operands will be same over here. Compare is going to be represented as IS06 and the operands A register and B will remain as it is. Bclt loop is having the entry of IS07 followed by LT and the loop. For the assembler directive, it will be represented as the AD,05. The next instruction, which is consisting of the literal, so the entry will be made as for the subtraction IS,02. A register will be represented as it is and the literal will be represented as the entry number, which is 3 in the literal table. Again, EQU loop will be represented as AD04 and loop. Multiplication of C register with B, it will be represented as IS,03. C register and B will remain as it is. The next instruction add followed by C register and the literal. So the corresponding variant 2 code will be IS,01. C register will remain as it is and the literal table entry number is 4 for the literal 10. So we are going to represent it by the pair L,04. The declaration statement ADS1, the corresponding entry, as it is a declaration statement, and for DS the numeric code is 2, so it will be represented as DL,02 followed by the constant value, that is C and 1. For BDS1, we are going to represent it as DL,02 followed by C, 1, and for R it is represented as DL,02. In the second pair, we are going to represent it as C, 1 as it is a constant, and the last instruction end presented as AD,02. So these are the two variants of intermediate code. I think all of you got the idea about how to represent the variant 1 and variant 2 by this particular lecture. So thank you for careful listening.